Hi everyone, in this video I'll walk through my approach to the M4 practice hackathon. The objective is to predict whether a loan applicant will default. Since the dataset is imbalanced, we optimize for F1 score, not accuracy. The training set contains around 55,000 samples with financial and credit related features such as age, income, employment experience, low amount, interest rate, and credit score. The target variable loan status equals to 0 for approved and 1 for default. And look at the target distributions. We see roughly as 3.5 to 1 imbalanced, far more approval than default. This confirms that accuracy would be misleading for and F1 is more appropriate. For numerical distribution, we noticed the clear outlier, extremely age above 100 and long right tail income. And the correlation heat map shows that strongest relation with the default uh, are loan percentage income, loan in rate, and previous loan default on file. And this features guide later feature engineerings. And I built a pre-processing pipeline with three main components. First, missing value handling. Numerical features are filled with the median, categorical with the mode. Second, outlier capping. Age is capped at 100, employment at 60 years, and income at the 99th percentile to reduce distortions. Third, features engineering. Financial ratios such as debt to income and integration terms like interest rate times loan percentage, K4 target encoding to prevent data leakage, a combined risk score count. After engineering, we expand to over 30 features. To address class imbalance, I tested five resampling strategies. And across these strategies, I trained 12 different models, giving 60 total combinations. The key finding is that the original unsampled data consistently outperformed all resampling methods. And SMOTE and ADASYN actually reduced F1 score, likely because uh, synthetic samples introduce noise, and the top performer on original data were XGBoost, LightGBM, CatBoost, all achieving F1 around 0.83 and 0.84. Based on the model comparison, I select XGBoost and LightGBM and CatBoost for tuning using Optuna. I run 100 trials for XGBoost, 100 for LightGBM, 50 for CatBoost. It's using stratified five-fold cross-validations. For imbalance handling, I use a model-native approach. Scales post weight for XGBoost in unbalance for LightGBM, auto class weights equals balance for CatBoost. All tuned models improve their cross-validation F1. Threshold optimization examples. Since F1 depends on the classification threshold, I start the threshold from zero point 0.2 to 0.65. The optimal threshold were lower than zero point 0.5. And improving recall while in maintaining precisions. Next, I built two ensembles, stacking ensembles and weighted voting ensembles. The weighted voting ensemble achieved the best validation F1 while remaining simpler than stacking. And the ensemble performed best overall. And all toned models achieve AUC above zero point 0.9, showing strong discrimination. And the precision recall curve confirms solid performance under imbalance. And using SHAP plot, the most important features were the previous loan default on file, loan percent income, risk score, loan interest rate, credit score. Engineered interaction features also contribute significantly. And as a benchmark, I run the H2O AutoML, which also confirmed that gradient boosting dominate this task. And the fivefold cross validation result shows low variance, indicate stable performance without overfitting. And for final submission, I retrained the tone models and on the full training data set. I then applied the optimized weighted voting sample with the select thresholds to generate prediction on the test set. This ensures that maximum data usage and optimal F1 performance. To summarize, the key improvement came from advanced feature engineering, model native imbalance handling, Bayesian hyperparameter tuning, and threshold optimization in sample blending. That concludes my walkthrough. Thank you for watching.